Hey class, this is Mr. Roberts at Shasta High, and kind of last minute I've decided it would be a good idea to go over the Chapter 8 tests. So your tests are scored, they're back, and I want to have you, take a moment to go over the questions you missed and see if you can figure out how maybe you can do better next time. So we're going to start, with the test, and I don't need that calculator there, so let me turn that off. And the first problem we'll look at is number 1, and it asks us to solve two systems of equations. And it says you can use any method that you want, right? But you're supposed to show your work and communicate kind of what you're doing. So as I look at this first system, the thing that I notice is the top equation has, I don't want that. The top equation has this value that's equivalent to 2y, right? It tells me 2y is the same thing as 7x plus 2. So I can see that there's 2y in the second equation. So without isolating the y, I'm just going to do a substitution like this. It looks a little unorthodox, but I'm going to rewrite that second equation as 5x plus 2y. What's 2y? Funny you should ask. 2y is 7x plus 2 according to the top equation. So this equals the number 26. When I combine these two terms, I get 12x plus 2 is the 26. Therefore, 12x is 24, and I believe that x is the number 2. Now that I know x is 2, my job is to figure out what y is. I think I'll go ahead and use just this top equation. The top equation tells me that, well, twice y is 7 times x plus 2. I know that x is 2, so that's why I've subbed that in there. So that's 14 plus 2 more, which is 16, and that's 2y. Therefore, y is the number 8. So our solution is the ordered pair 2, comma 8. X is 2 and y is 8. Let's go to the second equation, second system rather. For the second system of equations, I'm not crazy about these fractions. You know how I feel about this. However, I think I'm going to go ahead and set out and use substitution. So this big box right here is equivalent to 1y. So my strategy is I'm going to go ahead and rewrite this top equation, but instead of y, I'm going to place in this expression that's equal to y. So let's look at it. I'm trying to be neat because I could tell it's already messy with the fractions. I don't need to add any messiness to this. So I'm going to have negative 2x plus 3 times the quantity of y. Playing the part of y is this wicked expression, negative 1/4 x plus 41 halves. Okay, that's 3 times y. And then on the other side, I have that that's equal to 12. All right, well, let's try and deal with this a little bit. I'm going to go ahead and distribute this 3. So I get negative 2x, and then 3 times negative 1/4 is going to be negative 3/4 x. Okay. Oh, geez. I got 3 times. I'm looking for a calculator here. I've got 3 times 41. Oh, Robert, you can do that. It's 123, right? 41 times 3. Yeah. So that's going to be plus 123 halves, and that equals the number 12. Okay. Probably not necessary, but I'm going to do it anyways. I'm going to multiply both sides by the number 4 just because I want to get rid of all these fractions. So when I multiply each term on each side by the number 4, I get the following equivalent equation. I'm going to have negative 8x, and then I'm going to have negative 3x. That's beautiful, right? Because you can see this 4 is going to cancel with this 4. And then I'm going to have 4 divided by 2 is 2. So now I'm going to have 123 times 2, which looks like plus, oh, there's a plus here, plus 246. And on the other side, that's going to equal 4 times 12 is going to be 48. 4 times 12 is 48. Yeah, 48. All right, next, this is 8, 9, 10, 11. This is a negative 11 x, yeah, negative 11x. I'm going to subtract 248 from both sides. So I've got 48 that's positive, and I'm going to subtract 246 from it, rather. Take away 246. Really? 48 minus 246 gives me, oh, I'm not liking the look of that. I got I got negative 198. All right. That's just 48 minus 246. I've looked at it on my calculator twice. All right, next thing I'm going to do is I'm going to divide both sides by negative 11. So if I've got 198 divided by negative 11, it gives me x is 18. I have like almost no confidence in that value, but let's go ahead and figure out what y is and see if I can't convince myself that this point works in both equations. So if I was to set, where's this calculator at? There we go. I'm going to go ahead and, yeah, I do arithmetic on this. Let's go ahead and plug this value in and see what x is. So a little hard to see here, but it says that I'm going to take this 18 and I'm going to plug it into, gosh, I'm just going to go into this equation. I'm going to plug it in right here. So I'm going to go negative 1/4. So negative 1/4 times positive 18. I'm going to hit times 18. And then I'm going to say plus 41 halves. Plus 41 halves. It gives me the number 16. All right, so when I plugged 18 in here, it gives me that y is the number 16. So I think my ordered pair is x is 18, y is 16. If I want to double check that, I'm going to run that through that first equation. So again, this is going to be the number 18, and this is going to be 16. So I'm going to take negative 2 times 18, negative 2 times 18, plus 3 times 16, 3 times 16. And when I do that, I get 12, which is exactly what I should get. So it definitely satisfied that top equation. And I'm pretty sure it's going to work in the bottom equation because I think that's how I got those numbers. Let me just double check it though. So negative 1, I'm doing this twice. Negative 1/4 times x, which is 18, plus 41 halves gives me, yeah, very good. So I don't know. I didn't feel very confident. I was prepared to hunt down my mistake, but it looks like I got that. So let's move on. All right, let's move on to the second question. The second question says, a cruise ship left the Bahamas 3 hours before a private yacht. Now look, that alone tells me that there's some difference between how long each one's been traveling, the amount of time. The cruise ship left first. So because it left first, the cruise ship is traveling for more time than the yacht. So what I'm going to do is I'm going to choose to say let t be the amount of time that the yacht is traveling. Therefore, I know the cruise ship would be traveling more, 3 hours more. Is that the only way I can do it? No, I could go the other way. I could also say, hey, if t is the amount of time that the cruise ship is traveling, the yacht's traveling for less time, right? So this would be t minus 3. But both of them are capturing this relationship that in both cases, when I look at that, the cruise ship travels more, right? It travels more. And I guess I could leave it this way. It doesn't matter. The other thing that I know is that the vessels traveled in the same direction. So like they're starting somewhere and they're going in the same direction. One went first, the other one went later. So this right here is where they start. I guess this would be distance 0. And it says the cruise ship travels 25 miles per hour. So the cruise ship is 25. The units are miles per hour. And I guess, and these are hours too. So I'll say these units are hours. These units are hours. And the yacht traveled 40 miles per hour, 40 miles per hour. The question is, at what distance from the Bahamas will the yacht overtake the cruise ship? Oh, okay, so this is distance 0, but it's the Bahamas where they're starting and they're going away from the Bahamas on this same similar path. And the question is like, when will their distance be the same, right? So I'm going to say, hey, D is D, right? I want to know when these D's are the same. So I can write two equations, and this relationship we know because of dimensional analysis. If I take a rate and I multiply it by time, it gives me a distance. So the distance traveled is equal to rate times time. So the first equation is going to give me, hey, distance equals 25t. The second equation is going to give me distance equals 40. Now, the amount of time, let's be careful. The amount of time is this expression, t minus 3, right? So in both of them, I'm multiplying distance, rate times time, rate times time. It's just that the time here is an expression, so I need to be careful and make sure I get the whole thing. I want to know when they're the same distance from the Bahamas. In other words, when are they somewhere right in the future? They're right next to each other. So I want to know when the distances are the same. My strategy is I'm going to take the fact that I want to know when the two distances are the same. I've got one expression for distance, which is 25t. The other expression for distance is 40 times the quantity of t minus 3. So if I distribute this, this is 40t minus 3 times 4 is minus 120. And this is 25t. Yes, I'm picking up a calculator and I'm literally subtracting 40 from both sides. 25t minus 40t gives me the number 15. So I've got negative 15t is negative 120. And if I divide the negative 120 by the negative 15, I get the number 8. So I get that t is 8. All right. Now, those of you that did this and got it right, you got your answer based on the fact what t was. But if I look at this, remember, the cruise ship has been traveling for t is 8 for 8 hours, right? And the yacht has been traveling t minus or 8 minus 3 or 5 hours. So one's been traveling for 8 hours, one's been traveling for 5 hours. The big question is hey, how far are they from where they started in the Bahamas? To answer that, right, there's two ways to calculate the D. One of the ways is just 25 times 8, 25 times the number 8. And the other way is 40 times the quantity of 8 minus 3, or 40 times 5. And in both cases, I think 25 times 8 is 200, and 40 times 5 is also 200. So they are going to be next to each other at 200 miles from where they started in the Bahamas. So the answer there is 200 miles. By the way, this problem did say that you need to organize the information from this situation and write a systems of equations. So you have to write a system and you have to solve that system. So this is the system, right? Two ways to express D. You can see me solving it using the equal values method. And then I went back through and kind of double checked it with a bit of something. Next, plot the points BAT. So first of all, B is at the point, negative 6, 4. So here's B, okay. A is at negative 2, negative 2. Oops, don't move away. There's A. So I've got point B, I've got point A, and T is at 3, 3. Okay, here's T. And connect them to form a triangle. Okay, so let me sketch the triangle. I've got this line segment, I've got this line segment, and I've got this line segment right here. And the first question is find the perimeter of that triangle. All right, it's a Pythagorean theorem problem, right? I've got to figure out the height and the bases of these right triangles. That I've got to figure out this right triangle and solve to get this hypotenuse. That hypotenuse is part of the perimeter of BAT. This is 4 units. Right? This is 4 units right here. And this, I think, is, let's see, B is up at positive 4 and A is down at negative 2. That's a difference of 6 units. So I've got this right here is going to be 6 squared plus 4 squared. The square root of that is the length of segment BA, right? Another thing I've got is this AT. This is, what is it? This is at 3 to 2, so this is 5 units. And then I'm at -2 to 3, that's also 5 units. So again, I've resolved this to this right triangle, 5 units and 5 units. So this is segment TA or AT. AT is going to be the square root of 5 squared plus 5 squared. And then the last piece of this perimeter is the BT. So there's a 1 unit here. I can see the difference between the Y values for B and T. They differ by 1. And then this is, let's see, for B, that's at -6, and for T is at 3. That's traveling 9 units. So I've got 1 by 9. So this last one is going to be BT is going to be the square root of 1 squared plus 9 squared. All right, so I need to calculate those values, and I'm going to shamelessly flip to a calculator. I think I could handle it, but you know what? I'm going to go calculator anyways. So the first thing I'm going to have is the square root of 6 squared plus 4 squared. Great. Which gives me 2 root 13. Okay. The next part I'm going to have is the square root of 5 squared plus 5 squared, which gives me 5 root 2. Ugh, those can't be combined. The last one I've got is the square root of 1 squared plus 9 squared, which is root 82. That's awful. But the 3 of those together is the perimeter of this triangle. So perimeter, and I don't know how long these are. I'm just going to say generic units. But my perimeter looks like the following. It's going to be 2 times root 13 plus, I'll say 5 root 2, 5 root 2, and then plus root 82. Okay, that's my simplified radical form. If I want, I can convert it to a decimal. I can go grab this first number, got it, and I'll say plus the second number, got it. I'll say plus the third number, got it. Now that's what they are combined as a decimal. So it's equivalent to 23 point, I don't know, I'll round to the nearest tenth, 23.3. So I could say 23.3 units. I'll say approximately to the nearest tenth. All right, there we go. That is part 1. What is the perimeter of that triangle? Part 2 says, it says find the equation of a line that is perpendicular. Uh-oh. Let me circle that one I'm thinking about. Perpendicular means that I'm going to, if I've got a slope, if I have access to a slope, I'm going to want opposite reciprocal slopes, right? That's perpendicular to segment BA. Oh, okay, BA. BA, right? The slope of BA is down 6, so it's going down 6 over 4. So I know that's clearly a negative slope, right? So BA has a slope of -6 over 4, which is -3, down 3 over 2. That's the slope of BA, but I want to be perpendicular to it, right? I want to be perpendicular to that. So the slope I'm going to be using for my answer is going to be 2/3, which is the opposite reciprocal slope. Yeah. Multiply them, I get a number of -1, whatever. Now, it has to also pass through this point 4,4. So what I'm going to do is I'm just going to write it in point slope form, right? Y minus my known y value, right, is 4, equals my slope, which is 2/3 times the quantity of x minus my known x value, which is also 4. So that's a perfectly fine answer. If I want to, I could distribute and add 4 to both sides. So I can also say y is what? 2/3 of x minus 8/3 plus 4. Ugh. Minus 8/3 plus 4. Minus 8/3 plus 4. Oh, looks like positive 4/3. So I'm going to say, I'll just erase this. I did it right. It's plus 4/3. Plus 4/3. Beautiful. That's the equation of a line. In fact, if I wanted to check it, let's see. It has to go through 4, 4, which is right here. And I could go, let's see, I'm out of room, but I could go down 2 and then backwards 3. And I could go down 2 and backwards 3. And I could go down 2 and backwards 3. I don't know that that really helped me much, except, I mean, when I look at it, yeah, it looks like a right angle, right? But I don't have a protractor here, and these aren't very accurate drawings. But definitely, I've got the correct slopes, right? Because this slope was negative. This was down 3 over 2, and this slope is up 2 over 3. So I'm going to move on to the last part. It says, what is the area of triangle BAT? Well, I'm trying to find the area of this shape right here. And the area of this is a little difficult to find because it's not a right triangle, right? I don't see a base, I don't see a height. So what I'm going to do, my strategy is I'm just going to find the area of this big rectangle that I've enclosed with these green triangles. And once I know the area of that rectangle, I'm just going to subtract a few triangles from it. In fact, this is one triangle I'm going to take away. I'm going to subtract the area of this triangle and then the area of this little skinny triangle right here. So if I take away those 3 triangles from the area of the rectangle, I'm going to have the area of the triangle. The rectangle is 9 by 6, right? So the area of my rectangle is 9 times 6. And from that, I'm going to subtract some things. One of them is going to be 6 times 4, which is 24. 6 times 4 is 24, and half of that is 12. So I'm going to be subtracting 12. And the next part I've got is 5 times 5, which is 25. And 25 divided by 2 is like, what, 12.5? So minus 12.5. So I've taken care of this one and this one. The last one I need to subtract one more, and I'm out of room, so I'll say minus what? This one. What is it? 1 times 9, which is 9. Half of that is 4.5, so minus 4.5. So the area of that triangle B is 9 times 6 minus the number 12 minus 12.5 minus 4.5. And I'm just looking at my screen, making sure I got, 6 times 9. 6 times 9 was the area of the 9 times 6. 9 times 6 was the area of the original. Yeah, minus this was 12. Right? This was 12.5 and this was 4.5. Yeah, so I took all of these away. So in the act of taking those away, the only thing that remains is that triangle, and the area of that triangle is 25 units, and it's an area, so they're square units squared. All right, next question. All right, this says, write an equation in the form y equals that fits this table. So it says this is an arithmetic sequence. So I know this is growing by adding the same thing each time. I want to find that thing called the common difference. And I'm just going to use the slope to get that, right? So I'm just going to take the difference in my y's. I'm going to take 3 minus 5/3. That's this y value minus this y value over the corresponding x value minus the corresponding x value. So I love a calculator, right? So I'm going to grab a fraction. I'm just going to take 3 minus 5/3. Beautiful. That's my numerator. 3 minus 5/3, and I'm going to take 5 minus. Roberts, that's 4. I know. I'm just typing it anyways. So when I do that, I get that my growth is 1/3. All right, I'm adding 1/3. Now I can fill in these missing values, but before I do that, I want to back up 1/3 and go here. Now, this is 5/3. And I know if I take away one of those thirds from it, it's going to give me 4/3, right? And you're like, Roberts, are you sure about that? I've seen you do arithmetic. 5/3, right? And then I'm going to subtract 1/3, 1/3, 1/3, and I get 4/3. Yeah. So my 0th term is 4/3. And to move forward, right, I've got 4/3 plus 1/3. You can see the next one is 5/3. Beautiful. And then I go to the number 2. Yeah, that's 6/3, right? And then this should be 7/3. This should be 8/3. And that should be 9/3, right? So if I'm just double checking, I got 2, and then I got 7/3, and then I got 8/3, and then I got 9/3. So the table's complete, and I know the 2 things I need. I know my parameters. My slope parameter is 1/3. and my y-intercept parameter is 4/3. So the equation is y is equal to 1/3 times x plus 4/3. So that's that beautiful little linear equation right there. The next one we've got is it's a geometric sequence, right? So I know how this is growing. Its generator is multiplying by something. In fact, the multiplier is the parameter is b that we use. And if I think about this, I've got this number 6561. To move forward, I have to multiply by b. To move forward, I have to multiply by b. To move forward, I have to multiply by b. And as I look at it, you can see I multiplied by b 3 times, right? I've got 3 factors of b. In other words, 6,561 times b to the third, gives me 243. Okay, let's find out what b is. So b to the third would be 243 over 6561. Okay. Oh, I'm sorry, these are all off screen. Yeah, times b. So I've got the 6561 check grows, and grows, it shrinks down to 243 when I multiply it by 3 factors of b, right? So 6561 times b becomes 243. So we've talked about this. If I raise both sides to the 1/3 power, right, b to the third to the 1/3 is just going to equal b to the first. So on the other side, I'm going to just take 243 over 6561, and I'm going to raise that to the 1/3 power. And yep, I'm going to do it in one step on this calculator. So I'm going to have open parentheses 243 over 6561. I'm going to close the parentheses and raise it to the 1/3 power. And it tells me that my multiplier is 1/3. I raised it to the 1/3 power, and I got that my multiplier is 1/3. Okay, that's cute. So I'm multiplying by the number 1/3. Let's fill in our missing terms. So if I take 6561, and instead of multiplying by 1/3 to go forward, I'm going to divide by 1/3, and I get 19. I get 19,683. And I'm going to take that, and I'm going to divide it by 1/3 also. Boop. I get 59,000, and then 49. So this is 59,049. All right. So I'm going to take this and run it forward. So I'm going to go 59045. I press enter, and I want to multiply by a bunch of thirds to verify some things. So first of all, is the first term what I think it is? Yep, 19,683. The next term is, yep, 6561. And then I've got what? Boop, 2187. So this should be 2,187. And then I got, boop, 729. And then I've got, boop, 243. Yeah, got it. And then the last value there in the table should be 81. Okay. Well, I'm assuming it should be 81. So look, I'm happy with this. I know my parameters. I know my 0th term A, and I know my multiplier B. So I can write this rule. And I know it's a sequence, but I'm not using T of n notation. I'm going to use this y. So I'm going to write y is equal to 59,049 times 1/3 to the x power, right? So I could jump to any one of these by typing this in and then giving it the power I want. So if I type in x is 5, it's going to give me 243. If I type in x is 1, it's going to give me 19,683. All right, I think we're on to our second to the last page. What? Oh, here we go. This is good. Question number 5. We are supposed to simplify these expressions. My favorite trick to think about is that when I see an entire fraction raised to a negative number, I remember this. So just look, I'm going to take 2/3, which is a fraction, and I'm just going to raise this for simplicity to the power of -1. Observe what happens, right? This becomes, boop, 3 halves, right? It becomes 3 halves essentially to the first power. So I can make this negative exponent go away, right, by using this observation, right? I can go and say this is going to be 3x to the fourth power over 7. But now instead of being raised to the negative second power, it's being raised to the second power. So all I'm going to do is I'm going to square this thing. I'm going to multiply this fraction by itself. And because I'm just squaring it only, I can write it out, right? I'm just going to write, hey, this is going to be a 3x to the fourth over 7 times another 3x to the fourth over 7. My denominator looks like 7 times 7, which is 49. In my numerator, I've got 3 times 3, which is 9. And I've also got x to the fourth times another factor of x to the fourth, which is going to be x to the 8th power. X, not 8 to the x power, x to the 8th power. So my answer is 9x to the 8th over the number 49. So that's a great trick, right? A great trick. It's a great observation. Observing that on your calculator, the fact that, hey, if you have a fraction to a negative power, look what that does. That's amazing. In fact, if I took that same fraction and I raised it to the negative 2 power, to the negative second power, it's going to do the same thing, but it's going to go ahead and square those, and it's going to give me 9 fourths. There it is. Beautiful. All right, next problem. B. Let's see. Let's do this first. I've got a to the third in the numerator and a to the negative third in the denominator. And I do not want to make the mistake of thinking those are the same thing and that part of it equals the number 1. They are not the same thing, right? If I want to clean up that a to the negative third power, one strategy is I can multiply by a giant 1, the number 1, in the form a cubed over a cubed. And what's convenient about that a cubed is when I multiply this a to the third times a to the negative third, those two together become a to the 0 power, which is just equal to the number 1. So look, multiplying by this number 1 does not change my value, but it's really changing the format in a convenient way because these things now, I don't have a negative exponent. That's just the number 1. So it's like I multiplied by a 1, a to the third over a to the third, and I got a 1 in the denominator, right? And why did I pick a to the third? Here's my observation. These two together make a to the 0. A to the 0 equals 1. All right, so what do I have now? Well, across the numerator, right, I've got a to the third, a to the third, and a to the second. So that's 1, 2, 3, 4, 5, 6, 7, 8. I have 8 factors of a. I have 8 factors of a, which looks just like that, right? A, 8 factors of a. And I've got, in the numerator, I've got 4 factors of b. I also have 2 factors of b in the denominator. I need to clean that up, right? So if I've got 4 factors of b in the numerator, 2 factors of b in the denominator, that's just 2 factors of b in the numerator, right? We're thinking, hey, b over bb. These are gone, and I'm left with just b squared. So my final answer is going to be, what? That's b squared. Why is it b squared? Because it's bb. There's 2 factors of b. So my final answer is going to be 8, no, not 8, a to the 8th times b to the 2nd. Done. A to the 8th times b to the 2nd. Done. Next. Okay. Well, right off the bat, if I want to, I can take care of this b to the negative 2nd, right, by multiplying by the number 1 in the form b squared over b squared, right? Because this thing and this thing are now just equal to 1. So I'm not even thinking about those. They're not even there. I do have that this part right here, this part is being cubed, right? So that's an ab squared times ab squared times ab squared. And if I think about just that part by itself, that's going to be a cubed And you heard it. It was b squared, b squared, b squared, which is going to be b to the 6th power. And then I have still this a to the 4th power and a b to the 2nd. And now don't forget there's this also additional new b to the 2nd. So, and then down in the denominator, there's still an a to the positive 5th. Nice, right? Now let's just bring some things together. In my numerator, I have 1, 2, 3, 4, 5, 6, 7 factors of a. So I'm going to just write a to the 7th. And I also have 6, 7, 8, 9, 10. I've got 10 factors of b, right? BBB, BB, no, BBB, BBB, BB, BB. And then down here, I got a to the 5th power. Okay, a to the 7th over a to the 5th, that's a to the 2nd. It's a to the 2nd, right? If I wanted to, I can write like this, hey, a to the 5th times a squared. That's a to the 2nd, a to the 5th. You can see very clearly what happens, right? There's a giant 1 there. So it's gone. My final answer is I've got a squared, and I've got 10 factors of b, b to the 10th. A squared, b to the 10th. Last problem in this group. Ooh. I got a negative exponent thing. I know what I'm going to do. I'm going to use the same. I'm a one trick pony. I'm going to multiply by 3x squared to the positive 2 in both the top and bottom. 3x squared to the positive 2. What is just phenomenal about that is now this thing times this thing is 3x squared to the 0 power, which is just the number 1. So that's not a thought. It's just a factor of 1 in the denominator now. In my numerator at this point, I've got the 5x squared. And now let's go ahead and let's square the 3x squared, right? That's going to be 3 times 3, which is 9, and x squared times x squared, which is x to the 4th. And I do have one factor of x in the denominator still. All right, 9 times 5 is 45. This is x to the 6th over a factor of x. And then last step, right? One of these factors of 6, or x rather, is going to join with 1 from the bottom. I'm going to get an answer of 45x to the 5th power. 45x. Again, same idea, right? X to the 6th can be written as x to the 1st times x to the 5th. The denominator already had an x to the 1st. Those are gone, and that's why I'm left with x to the 5th. All right, last 2 problems on this page. Solve some equations. This first one, great candidate for that thing we will call looking inside. In fact, I want to really truncate this. I'm looking at this right now, and this whole chunk right here, that has to be the number 5, right? Why? Because 5 plus 12 is 17. All right, if that has to be a 5, that means that this thing that lives inside here has to be the number 25. Why? Because the square root of 25 is going to give me 5. So here's my thinking. This 8x minus 7 has to be 5. Right? Therefore, the thing inside, the 8x minus 7, has to be 25. If that 8x minus 7 was 25, boom, the square root of 25 would give me 5, check, and then 5 plus 12 would give me 17. So this is what I want. I'm going to add 7 to both sides. I get that 8x is 32, and I'm going to divide both sides by 8. X has to be the value 4. X is 4. Again, if I'm sitting in here, 4 times 8 is 32. 32 minus 7 is 25. Square root of 25 is 5. And 5 plus 12 is 17. It checks. So when I do this, 17, I get 17 on both sides. So it most definitely checks. Next problem is a great candidate for fraction busters. I can see that my denominators have factors of 2. There's a factor of x, and there's a factor of 5, right? So 2 times x times 5, or 10x, will destroy all of these fractions in one swoop, right? So I'm going to go ahead and write this step out. Look, I'm going to be pushing in a 10x times 7 over 2x plus a 10x times 9, and that will equal a 10x times 12 over 5x, and then plus a 10x times 6. So if I look closely, what's happened is every single term has just picked up factors of 2x and 5, otherwise known as 10x. Now I cleaned up the fractions because they're all going to go away. 10x divided by 2x is 5. This becomes 5 times 7 plus 10x times 9. Don't forget those are factors. This becomes 90. On the other side, 10x divided by 5x is going to become 2. This is 2 times 12. Or let me just write 24. Okay. You're going to make a mistake right there, Rob, maybe. And then plus 10x times 6, which is 60x. So I've got 35. There's no x there. However, 10 times 9 is 90x. Oh, that was a close one. Well, I would have realized it didn't. When my answer didn't work, I would have probably found it, but it's better to find it now. So I guess I'm going to subtract 60x from both sides. That's going to leave me 30x here, and that's 24. And if I subtract 35 from both sides, that's going to give me that 30x is going to equal to, gosh, that's negative 11, right? 24 minus 35, 24 minus 35. Why not look at it? 24 minus 35, I don't know. It's negative 11. Perfect. So my answer then, I need to divide both sides by x. X is going to equal negative 11 over 30. And that, I know that doesn't reduce because negative 11 is prime. So I'll just go ahead and write that down here up at the top. X is negative 11 over 30. I want to check that on my calculator. Remember this technique I showed you guys a while back. I can take negative 11 over 30, press enter, and then I can store that as x. So there's a button right here that says store, S-T-O with an arrow. Store that, and then I hit the variable button, x. So I'm going to take that, and I'm going to store it as the variable x. Boop. So now this calculator believes x is negative 11. I can ask it, hey, what's x? And it says it's negative 11 over 30. Okay. I'm going to now evaluate the left and right hand side. So the left hand side is 7 over 2x, right? Leave the denominator plus 9. So I didn't leave the denominator. I said leave the denominator, but I didn't. Leave the denominator plus 9. So 7 over 2x plus 9 is negative 6/11. The other side is 12 over 5x, and then I have to go plus 6. That is, I made a mistake, 12. Oh, I did it again. Look at this. This is so goofy. I have to leave. It's 12 over 5x plus 6. Boom. Yeah. Now I'm a little disappointed because these would be right next to each other. But if I go back up, you can see the previous one, right, when I evaluated it was negative 6/11 also. What that lets me say is, hey, both of these are negative 6 over 11, right? The left-hand side and the right-hand side both became that. That's why I can say this is most definitely a solution. X is negative 11 over 30. Last page, we're just going to talk about the top problem, that one that was a bonus question I'm not going to discuss. Top problem says Mr. Grigsby. We know Mr. Grigsby. We know him. We know that guy. Mr. Grigsby has decided that because he got a bonus from like selling drones or something, I don't know, or he was flying drones, or he helped someone fly drones. He got a bonus of $775, and being the nice dad he is, he decided, hey, I'm going to divide it up amongst my 3 daughters. Now, the 3 daughters are probably not going to like how this is working, and I don't know his justification, but he's decided the oldest daughter is going to get twice as much as the youngest. I'm fine with that. I'm the oldest son. And the middle daughter is going to get $35 more than the youngest. Okay. So I don't know if you noticed this, but both of those expressions, the amount they're getting was described in terms of what the youngest daughter gets. So I'm going to identify a variable. I'm going to say let y be the dollars that the youngest daughter uh, gets. Receives, daughter gets. Okay, so that's what y is. So now let's write this down. Okay, so there's 3 people that are getting money. We've got the youngest daughter, and she's going to get y dollars. That's my definition. Plus, the oldest daughter is going to get twice what the youngest daughter gets. So that's just going to be 2y, right? So that's the youngest daughter gets y, the oldest daughter gets twice y, and the middle daughter is going to get $35 more than the youngest. So that's y plus $35. And the amount of money he's divvying up is $775. So if I look at this, there's a y plus 2 more y's plus another y. So that's 1, 2, 3, 4 y's being added together, right? Y plus y. That's what 2y is. It's y plus y plus another y plus $35 has to equal 775. So, yep, I'm right here in my calculator. 775 minus 35 gives me 740. Not ashamed to use that calculator. 4y is 740. And I'm going to divide by 4. 740 divided by 4 gives me $185. So y is 185. So I know that the youngest daughter is going to get 185. So I'm just going to write youngest, middle daughter, and oldest. The youngest daughter is going to get $185, right? If I take 185 and I add 35, I get 220. So the middle daughter is going to get $220. And then if I take the 185 and I double it times 2, I get the oldest is going to get $370. So 370. Now, those numbers, just as a check, should add up to $775. So I want to verify that. I've got 185 plus 220 plus 370 equals $775. So that's exactly what we're looking for, right? This totally checks, and that is my solution. Hey, class, if you have questions, you want to discuss some things, you hear me talk about things, you're like, hey, I don't really know what you mean when you say this, or can you help me with this? Stop by. The room is open. I try to open up a half hour before school starts. I'm in here at lunch. The door should be open. If it's not, just knock. And I'm here after school as well. So this is Mr. Roberts. I hope to see you soon. Have a good rest of your day.